We have a house that runs entirely off solar energy.
These panels, there's 30 more panels on the roof too. It's not just these 6.
This is our wall assembly. If you'd like to hear about that, I can talk to you about it over here.
And we have a house that can do that in a cold climate like Minnesota.
The snow-covered ground can be a very significant reflector, so it'll allow us to collect that reflected light as well.
And we have a house that actually produces a net surplus over an entire year.
They produce 13 months of electricity in a 12-month period of time.
So if we built a lot of houses like ours, these houses would help existing houses meet their demand and essentially reduce our overall consumption of energy as well as contribute renewable energy to the power grid.
Our documentation on this house, just in the plans alone, was over 190 pages.
Wow.
I like how they come in, it's like, oh, I like this one the best. It's like, it feels like a home.
Well, a team of us actually came out to the 2007 Decathlon, and I would say the design process really started then. We interviewed the other schools, really observed what they did, some strategies, and we noticed that a lot of schools were really just applying technology but not thinking about the home.
We didn't want a technical box. We wanted to make sure that the house represented something that people could be familiar with, that they could associate home when they saw our house. And that's where the Icon House name came into play. We started with the traditional gable shape and we adjusted that shape by changing the angle of the south part of the gable roof to be more appropriate for solar. We essentially kept playing with the angles and the surface areas that we could get within the size limitation of the rules.
It was essentially long back and forth before we finally settled on this design, and where the engineers could say, well, this design gives us this output. And that's acceptable to us. And then the architects were also saying, well, we have a design where we think represents the traditional gable, and we can move forward.
And we were really excited about that process of design as well, because we were playing with both performance and aesthetics. So that was a really important design feature of the house. It essentially shaped the outside, it really created that familiarity with home, and it was also part of the technology and the actual performance of the house. So that was one of my favorite design features.
So my major role in the project was to model the house, and we did a fairly extensive modeling of all the solar thermal systems, all the photovoltaics, the HVAC systems, as well as the house envelope, and we incorporated that into a model using software that we could also simulate the weather and the competition conditions and the loads that we need to undergo during the competition. And essentially we would produce results for how our various systems were performing, where the problem areas were, where we could make improvements, and our whole design effort was essentially a back and forth between the results that we were getting from our model and the decisions we were making in the engineering design as well as the architecture and interior design teams.
Shield, which it prevents radiant heat loss. It's a mirror. Radiant heat stays in or out.
So you see, they're monocrystalline silicone laminated in glass, and that picks up the majority of light to convert into energy.
Right.
One unique thing that we do on our house is we try to identify where we're wasting energy and try to come up with another use for that energy. Our best example of that is the solar thermal panels. Due to our shallow slope, they tend to have a problem in the summer called overheat, where we actually can heat all the water in our tanks, and once that happens, we can't really use our solar collectors for anything. So in order for that to not happen, we decided to build a dehumidification system that'll actually use thermal energy to humidify the house. And so that gives us a use for this energy that would otherwise be wasted in the summer. And since we only dehumidify in the summer, that system doesn't operate in the winter, and we can use the full solar thermal energy in the winter for hot water and home heating.
We have this huge solar thermal system because we need to heat our house in the middle of Minnesota in the middle of the winter. And so what do we do with the excess heat that we generate in the middle of the summer, which is, blazing hot here? Our Minnesota ingenuity figured out how to use that excess heat to help with our cooling.
Like, our solar thermal system was pretty amazing. As far as solar thermal systems go, a lot of people just kind of have an off-the-shelf thing, so they buy everything from like one company. We really put some stuff together and designed it for year-round use. which is very rare to have a solar thermal system that'll work in winter and summer, because summer overheating is a big problem.
So we have basically a liquid desiccant based dehumidification system. Liquid desiccant is a salt slurry that's likes to absorb water. So people are familiar with those little silica gel packets that come in their shoes. They do that so they keep your shoes dry before you buy them. Essentially, we have a giant column of that, and we pass humid air through it, and it pulls water out of the humid air and puts dry air in our house. And we use the solar energy then to heat that salt solution up, and it drives off water that we evacuate outside the house. So if we run this process in a continuous loop, we can keep the inside dry and keep exhausting humid air outside the house using solar thermal energy.
From the house right here, and these two streams will cross, and some of the moisture will go into the solution.
It allows water vapor to escape the walls of the house
Right, but then the advantage is the cost would be lower and probably more efficient new technology.
Other than, of course, obviously the very first competition, we were the university that placed highest the first time we ever competed of any university in the country, in the world. So I think that that says a lot about all of the great talent and energy that we put into this. I think it was really gratifying to come in first in engineering when we all knew that the Germans had outspent all of us many times over. And I think our sense, and it wasn't just Minnesota's sense, I think most of the American universities sensed that Germany assumed that they would come in first in engineering. So to come in first in engineering and to beat Germany at their own game was really gratifying.
Mechanical shed here. It houses 700 gallons of domestic water storage. We had to bring our own water to the mall. Hot water storage.
Well, the red strips, or the strips, were a nod toward Minnesota vernacular housing, you know, like the traditional kind of farmstead.
Water, puts water away from everything. Okay, that keeps it.
Very few of us even knew each other, didn't even know of each other's majors, weren't really sure what architects brought or what the engineers brought or what the construction students brought. And we really committed to work together as a team. The students had the power, they drove the project, and we met weekly and then daily and then hourly. You know, we were together for those 2 years, really pulled off what I think was a successful house. Josh Cannell and Julia Haltewanger just did an amazing job on the whole energy model and worked really closely with Jane Davidson here at the university to, you know, put together a really accurate, highly thought out model of how our house would perform over a year, over 12 months. Without question, I think that really added to our points in engineering. So we were able to show how our house would perform. We were able to make improvements on, you know, the inputs to that energy model and really tighten up our house. And then we were able to document it. So all of that went into our submittal in December, and I think it really impressed the judges. Then I think also having the desiccant system and having, you know, our really excellently laid out mechanical shed and all of the engineering elements of our house together really sealed the deals. So our engineering team was awesome, and I think the really great story of that is, you know, Peter Lehman is an undergrad in mechanical engineering. He has this idea of a desiccant system. He works together with the facilities guy here at the U. You know, they mock it up, and they actually got it installed and showcased at the competition. I think that's a great story, and that was really fun to see.
Years from now, when they make a movie about University of Minnesota's solar decathlon house, well, first of all, who would play me is the big question. I don't know, maybe one of those Twilight dudes. Okay, but